Final example today, example 2, going backwards and out of order here. Fill in the Venn diagram with the sets natural, whole, integer, rational, and irrational. And the whole box here represents real numbers. So when we see real numbers up at the top, it's simply stating this entire picture represents every real number in the world. Okay, so we have a box here that represents a container for all the real numbers in all the world. So all infinity of them are in there. Okay? And then we're breaking it into parts. So the first thing I do with the set of real numbers doing a Venn diagram is I work with the disjoint sets. All right? Those disjoint sets are rational. That should be Q instead of R. I don't know why I put an R there. Rational and irrational. That's where I start. So the rational, the irrational are disjoint, which would be these two guys, right? That's one, this is the other. Which one do you think is which? Which one's this one?
Irrational.
Irrational. And this one over here?
Rational.
Is rational. Okay, the reason I know this one's rational is because there's subsets, right? There's pieces, the rational broke into extra pieces where irrational didn't. So this side's done. All right, this bar here says that either you're in this group or in this group. Think of it as a club. All right? We're inside this club and there's rules for how you get into different rooms, right? So this is the coolest place to be right here, but this is cooler than that because there's subgroups, right? So irrational, rational, split in half or in pieces. All the irrationals belong in that room, all the rationals belong in this room. Okay? The next biggest set is what?
Integer.
Integers, okay? So we have this huge room here for all these real numbers, right? And then we have these smaller rooms inside this room. And the biggest one is integers, so that's going to go right here. Notice that integers are inside of rational numbers, right? Because every rational number is listed, every integer is going to be in that list also, along with fractions and decimals. So the types of numbers out here, outside this, 1/2 is out there, and 2/3, and 0.6, and 1.97. Those types of numbers are out there, right? What's inside the integer group is going to be -2 and 4. Oh, hold on. -2 and -3 and -7 and -10 and 4 and 3 and 1 and 2 and 0. All right. I just start throwing numbers in there. Okay. Look at the integer circle. The integer circle is right here. And inside the integer circle, all these negative numbers and all these positive numbers and 0, right? But as we keep moving our way in, the whole numbers are here, right? That's my whole number circle. 0 is a whole number, so are 1, 2, 3, and 4. And then I move in further, then I got my natural number circle, which is right here. That's just natural numbers. So 1, 2, 3, 4, 5, 6, ... right? All those are in there. If they're in N, they're also in W, so all the 1, 2, 3, 4, and all that ... is there, plus the 0. But 0 is outside of N, inside of W. All these numbers are inside of Z, so are the negative numbers, but their negative numbers aren't inside of W. And all these fractions and decimals are outside here, but so are the integers and the whole numbers and the natural numbers, right? So this Q is everything inside here, all your decimals and fractions, all your integers, negative, all your whole numbers, 0, and all your natural numbers, 1, 2, 3, 4, and so on, right? So that's what the Venn diagram does for us. It gives us a visual representation of how those sets represent. If something's inside of something else, it's a subset. So N is a subset of W, N and W are both subsets of Z, N, W, and Z are all subsets of Q, N, W, Z, Q are all subsets of R, I is a subset of R, I and Q have no relationship with each other. So that's all that Venn diagram is telling us. You should be able to recreate that whenever I ask. Okay? I believe that happens on a test at some point in time. So be able to do that.